Picture this. You're lying in bed, eyes heavy, and somewhere out there, right now, there might be something looking back at us. Not in a scary way, just looking. I've been thinking about this question a lot lately. Are there planets in our solar system where life could exist? It's one of those thoughts that creeps in when you're staring at the ceiling at 2 a.m. And honestly, the answer might surprise you. Let me take you on a journey through our cosmic neighborhood. We'll visit places that could harbor life, or at least places where scientists think life might have a shot. Some of these worlds are familiar. Others, well, they're stranger than you might imagine. Mars feels like the obvious starting point. It's our neighbor, sitting just one planet over. We've sent dozens of robots there, and they've been busy taking photos and drilling into rocks. Actually, if you think about it, Mars is probably the most photographed planet after Earth. The thing about Mars is that it wasn't always the cold, rusty desert we see today. Scientists have figured out that billions of years ago, Mars had a thick atmosphere. It had rivers, lakes, maybe even oceans. The planet was warmer then, warm enough for liquid water to exist on the surface. But something happened. The atmosphere thinned out, swept away by solar winds. Without that protective blanket, the water evaporated or froze. The planet turned into what we see now, a frozen desert where temperatures can drop to minus 200 degrees Fahrenheit at night. Yet here's where it gets interesting. In the ice caps at Mars's poles, there might still be primitive life. Bacteria, maybe microbes. We found similar organisms living in the ice of Antarctica, surviving in conditions that would kill most other life forms. If they could do it here, why not there? The landscape of Mars tells stories of its watery past. There's this massive canyon system called Valles Marineris that stretches for over 2,500 miles. That's longer than the continental United States is wide. It runs up to 5 miles deep in some places. Imagine standing at the edge of that canyon, looking down into shadows that haven't seen sunlight in millions of years. And then there's Olympus Mons. This volcano is 16 miles high, nearly 3 times taller than Mount Everest. It's so massive that if you stood at its base, you wouldn't even be able to see the summit. The curve of the planet would hide it from view. The volcano is dormant now, but when it was active, it would have pumped gases into the atmosphere, maybe creating pockets of warmth where life could have thrived. Scientists keep finding evidence that Mars was once more Earth-like than we thought. Dark streaks that appear and disappear with the seasons. Methane emissions that shouldn't be there. Underground lakes of liquid water discovered just a few years ago. I sometimes wonder what it would be like to stand on Mars during one of its dust storms. The wind can reach 400 miles per hour, whipping up clouds of rusty dust that engulf the entire planet. But here's the strange part. Because the atmosphere is so thin, you'd barely feel the wind at all. It would be like standing in a gentle breeze while the world turns orange around you. Now, Venus. Venus is a different story entirely. If Mars is the planet that lost its chance at life, Venus is the planet where everything went catastrophically wrong. From a distance, Venus looks beautiful. It's the brightest object in our night sky after the moon. The ancient Romans named it after their goddess of love and beauty. But get closer, and you realize Venus is basically hell with better PR. The surface temperature is 867 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure would crush you like a soda can at the bottom of the ocean. And it rains sulfuric acid. But wait, there's more. Actually, I should probably mention something that surprised me when I first learned it. Venus has over 50,000 volcanoes. 50,000. Some of them create lava channels that run for thousands of miles. The longest one is 4,200 miles, longer than the Nile. The surface of Venus is young, geologically speaking. It's been completely resurfaced by volcanic activity relatively recently. There are these weird circular formations called pancake domes. Imagine dropping pancake batter from a great height onto a hot griddle. That's essentially what these are, except the pancakes are made of lava and they're miles wide. Here's the twist, though, and this is where things get interesting for our search for life. Up in Venus's clouds, about 30 miles above the surface, conditions are surprisingly Earth-like. The temperature is reasonable. The pressure is similar to Earth's surface. And some scientists think just maybe there could be microorganisms floating up there. Think about it. On Earth, we've found life in the most unlikely places. In boiling hot springs, in pools of acid, deep in rocks where no sunlight ever reaches. If life can survive those conditions, why not in the clouds of Venus? The clouds themselves are thick enough to completely hide the surface. Standing on Venus, if you could somehow survive, you'd never see the sun or stars. Just a dim, reddish glow filtering through the eternal overcast. It would be perpetual twilight in a pressure cooker. Let's leave the inner planets and head out to Jupiter. Jupiter itself is a monster, so big that all the other planets could fit inside it with room to spare. But we're not interested in Jupiter. We're interested in one of its moons, Europa. Europa looks like a cracked egg from space. Its surface is covered in ice, crisscrossed with dark lines that look like veins. These lines tell us something remarkable. Beneath that ice, maybe just 6 miles down, there's an ocean. A real, liquid water ocean. Actually, let me correct myself. Europa's ocean might contain twice as much water as all of Earth's oceans combined. Just sitting there hidden under the ice. The ice crust itself is fascinating. It's constantly shifting and cracking, creating those distinctive lines. Sometimes material from the ocean below seems to well up through the cracks, staining the ice red with minerals. It's like the moon is bleeding. But here's the really exciting part. The basic ingredients for life, organic chemicals, water, and energy, they're all there. The water stays liquid because of tidal heating. Europa's orbit around Jupiter isn't perfectly circular, so the moon gets squeezed and stretched by Jupiter's massive gravity. This creates friction, which creates heat. On Earth, we've found entire ecosystems living around deep-sea volcanic vents, completely cut off from sunlight. They get their energy from chemicals in the water instead. The same thing could be happening in Europa's dark ocean right now. While you're lying there, trying to fall asleep, there might be alien fish swimming around in the darkness beneath Europa's ice. I know. Alien fish sounds like science fiction, but the science is solid. In fact, scientists are so interested in Europa that multiple missions are being planned to study it more closely. One will orbit the moon, scanning the ice with radar. Another might actually land and drill through the ice to sample the ocean below. Just imagine what we might find. Saturn's moon Titan might be the weirdest place in our solar system that still somehow feels familiar. And I mean that in the most unsettling way possible. Titan is huge, bigger than the planet Mercury. It has a thick atmosphere, thicker than Earth's actually. It has weather, seasons, rivers and lakes and seas. From a distance, you might mistake it for Earth, until you realize those rivers and lakes aren't filled with water. They're filled with liquid methane. The temperature on Titan is about minus 290 degrees Fahrenheit. At that temperature, water is rock hard. Literally, the mountains on Titan are made of water ice, carved into shape by flowing methane, the same way water carves mountains on Earth. It rains on Titan. Actual rain, falling from clouds, pooling in lakes. Except the rain is methane, and it falls in slow motion because of the low gravity. A raindrop on Titan would take 3 times longer to hit the ground than on Earth. Imagine standing there, in a very good spacesuit, watching the rain fall like it's in a dream. The largest sea on Titan is called Kraken Mare. It's bigger than all the Great Lakes combined. There are islands in it, coastlines, probably waves, though they'd move slowly, almost hypnotically. Scientists think the sea might be 500 feet deep in places. But here's what really gets me. Titan has sand dunes, vast fields of them, made from organic compounds that rain down from the atmosphere and dry into particles. These dunes could be hundreds of miles long and 500 feet high. The wind that shapes them only needs to blow at about 2 miles per hour because the gravity is so low. Some scientists think Titan might be what Earth was like before life began. All those organic chemicals, all that liquid, all that energy from Saturn's gravity. It's like a frozen-in-time version of early Earth. Or maybe, just maybe, it's not frozen at all. Maybe something is happening there, very slowly in the cold. There's been talk about sending a submarine to Titan, an actual submarine, to explore those methane seas. Can you imagine? A robot submarine sailing alien seas, looking for signs of life in liquid that would be gas on Earth. Sometimes science makes science fiction look unimaginative. Oh, and I should mention, Titan is the only moon in our solar system with a substantial atmosphere. When the Huygens probe landed there in 2005, it transmitted for 90 minutes from the surface. The photos it sent back showed rounded pebbles, probably smoothed by flowing liquid, scattered across a plain. It looked almost normal, like a dried riverbed in Arizona, except it's a billion miles from Earth, and those aren't water-worn rocks. Saturn has another moon that's caught scientists' attention. Enceladus. It's tiny. You could drive across it in a few hours if there was a road. But this little moon is doing something remarkable. It's shooting geysers of water into space. Huge geysers hundreds of miles high. The first time scientists saw this, they couldn't believe it. Here's this small, frozen moon, and it's literally spraying water into space like a cosmic fountain. The water comes from an ocean beneath the surface ice, kept liquid by the same tidal heating that warms Europa. But here's the kicker. When scientists analyzed the water in those geysers, they found organic molecules. Complex organic molecules. The kind that, on Earth, are associated with life. The geysers are constantly refreshing the moon's surface with new ice, which is why Enceladus is the most reflective object in our solar system. It's literally the shiniest thing we know of, reflecting 99% of the sunlight that hits it. It's so bright it looks almost fake, like someone forgot to add texture in a video game. Standing on Enceladus would be surreal. Actually, wait, I just realized something. The gravity is so low that if you jumped, you'd go up about 140 feet. That's like jumping to the top of a 14-story building. You'd have plenty of time to look around on your way up and down. 3 or 4 minutes, probably. The ocean beneath Enceladus's ice might be global, wrapping around the entire moon. It's salty, like Earth's oceans. It has energy from tidal heating. It has organic molecules. It has everything life needs, as far as we know. Sometimes I think about how there are more places in our solar system with oceans than without them. Earth, Europa, Enceladus, probably Titan in a way. Maybe others we haven't discovered yet. All that water, all those possibilities hidden under ice or clouds. Not every moon is a potential haven for life. Some are just straight up terrifying. Take Io, another of Jupiter's moons. Io is the most volcanically active place in our solar system. It has seas of molten sulfur, rivers of lava at 3,000 degrees Fahrenheit, volcanoes that shoot sulfur 300 miles into space, so high that some of it escapes Io's gravity entirely. The entire moon is basically turning itself inside out constantly. The surface you see today won't be the same surface in 20 years. It's like the moon has chronic indigestion, except the indigestion is made of sulfur and lava. Standing on Io would be, well, you wouldn't stand on Io for long. Besides the lava and the sulfur and the constant volcanic eruptions, you'd be bathed in radiation from Jupiter's magnetic field. It would be like getting 1,000 chest X-rays every second. But even Io plays a role in the possibility of life elsewhere. Its volcanoes pump sulfur into Jupiter's magnetic field, which then rains down on Europa, providing potential chemical energy for any life that might exist there. Everything's connected in weird ways out here. Actually, I just remembered something odd about Io. Despite all the volcanic activity, the average surface temperature is minus 230 degrees Fahrenheit. So you have lakes of molten sulfur next to frozen sulfur dioxide snow. Fire and ice existing side by side. Nature doesn't care about our expectations. Way out past Neptune, in the Kuiper Belt, there are thousands of icy bodies orbiting the sun. Some of them, like Pluto, are big enough to be called dwarf planets. Others are just chunks of ice and rock, leftovers from when the solar system formed. But even here, in this frozen wasteland, there might be surprises. Some of these bodies might have subsurface oceans, kept liquid by radioactive decay or leftover heat from their formation. Pluto itself shows signs of geological activity that nobody expected. The dwarf planet Ceres, which sits in the asteroid belt between Mars and Jupiter, might have a layer of liquid water beneath its crust. It's got bright spots that might be salt deposits from water that reached the surface and evaporated. We keep finding water in places we didn't expect. We keep finding organic molecules where they shouldn't be. We keep finding energy sources in the darkness. You've probably heard of the Goldilocks zone, the distance from a star where liquid water can exist on a planet's surface. Not too hot, not too cold, just right. Earth sits in the sun's Goldilocks zone, which is why we have oceans instead of ice or steam. But the more we explore a solar system, the more we realize the Goldilocks zone might not be the whole story. Jupiter's moons are way outside the zone, but they have liquid water. Titan has liquid on its surface, just not water. Venus's clouds might harbor life, despite the planet being too close to the sun. Maybe we've been thinking about this all wrong. Maybe life doesn't need conditions to be just right. Maybe it just needs them to be consistent, stable enough for chemistry to do its thing, whatever that thing might be. I read once that there are more stars in the universe than grains of sand on all of Earth's beaches. Our sun is just one star. Our solar system is just one system. And in just this one system, we've found multiple worlds that might harbor life. The odds feel good, don't they? Here's something I've been wondering about. What exactly are we looking for when we search for life? We say water, organic molecules, energy, like it's a recipe. Add ingredients, stir, wait 4 billion years, and voila, life. But Earth's story is more complicated than that. Our planet went through hell before life appeared. It was bombarded by asteroids for millions of years. One impact was so massive it tore off a chunk of the planet, which became our moon. The surface was molten. The atmosphere was toxic. And then, somehow, in some warm pond or deep-sea vent, chemistry became biology. Non-living molecules figured out how to make copies of themselves. And once that started, it never stopped. The thing is, we only know one way life happened. Our way. Carbon-based, water-dependent, DNA-using life. But what if there are other ways? What if life on Titan uses liquid methane the way we use water? What if Europa's ocean has creatures based on sulfur chemistry? What if we're looking for Earth-like life when we should be looking for something else entirely? Scientists have actually thought about this. A lot. They've come up with ideas about silicon-based life, since silicon has similar chemical properties to carbon. Or ammonia-based life, since ammonia stays liquid at much lower temperatures than water. or even plasma-based life in the atmospheres of stars, though that one seems like a stretch. But every time we find life in an extreme environment on Earth, it expands what we think is possible. Bacteria in nuclear reactor cooling pools, organisms in solid rock miles underground, microbes that can survive being exposed to the vacuum of space. Actually, that last one is particularly interesting. We found that some Earth bacteria can survive on the outside of the International Space Station. They go dormant, basically freeze drying themselves, and wake up when conditions improve. It makes you wonder, could life hop between planets? Could a meteor impact on Mars billions of years ago have sent bacteria to Earth? Are we all Martians? Hashtag the magnetic shield we take for granted. There's something about Earth that we don't think about much, but it might be the most important thing for life. Our magnetic field. It's invisible, but it's basically a force field protecting us from the sun. Without it, solar wind would strip away our atmosphere like it did to Mars. Our oceans would evaporate. The surface would be bathed in deadly radiation. Earth's magnetic field is created by our planet's molten iron core spinning around. It extends thousands of miles into space, deflecting charged particles from the sun around the planet. You can actually see it working sometimes. The aurora borealis, the northern lights, that's our magnetic field directing solar particles toward the poles where they collide with atmospheric gases and create those beautiful light shows. Mars used to have a magnetic field, but its core cooled and solidified. Without that protection, its atmosphere was slowly blown away by solar wind over millions of years. Venus doesn't have a magnetic field either, though its thick atmosphere provides some protection. Europa and Ganymede, Jupiter's moons, actually have weak magnetic fields. Ganymedes is strong enough to create its own little magnetosphere within Jupiter's massive one. It's like a bubble within a bubble, protecting the moon from some of Jupiter's radiation. This makes me think, when we look for habitable worlds, we need to look for more than just water and warmth. We need to look for shields, protection, stability over geological time. Life needs time to develop, and time requires protection from the universe's tendency toward chaos. Hashtag the Fermi paradox keeps me up at night. Sometimes when I can't sleep, I think about the Fermi paradox. Actually, that's probably not helping you fall asleep. But hear me out. The paradox goes like this. There are billions of stars in our galaxy. Many of them are older than our sun. Many of them probably have planets. Some of those planets probably developed life. Some of that life probably became intelligent. So, where is everybody? Why haven't we detected any signals? Why haven't we seen any evidence of alien civilizations? The galaxy is old enough that even traveling at sublight speeds, an alien civilization could have colonized the entire thing by now. But as far as we can tell, we're alone. There are lots of proposed solutions. Maybe life is incredibly rare. Maybe intelligent life is even rarer. Maybe civilizations tend to destroy themselves. Maybe they're out there, but we're looking in the wrong way. Maybe, and this one's kind of unsettling, maybe they're intentionally avoiding us. Or maybe the distances are just too vast. Even our nearest star neighbor, Proxima Centauri, is 4.2 light years away. If we could travel at 10% the speed of light, which we can't even come close to, it would still take 42 years to get there. And that's the nearest star. But then I think about our own solar system and how many potentially habitable worlds we've found just in our own backyard. Europa, Enceladus, Titan, maybe Mars, maybe Venus's clouds. If our one solar system has this many possibilities, what about the billions of other systems? Hashtag the universe is trying to tell us something. You know what's crazy? We can see the past. Right now, when you look at the stars, you're seeing them as they were years, decades, centuries ago. The light from the nearest star left 4 years ago. The light from stars across the galaxy left when humans were still figuring out agriculture. Some of the stars we see might not even exist anymore. They could have exploded centuries ago, but the light from that explosion hasn't reached us yet. We're looking at ghosts, the pillars of creation, that famous photograph from the Hubble telescope, those massive columns of gas and dust where new stars are being born. They were probably destroyed by a supernova 6,000 years ago, but they're 7,000 light years away, so we won't see their destruction for another 1,000 years. We're looking at something that probably doesn't exist anymore, watching baby stars being born in a nursery that's already gone. It makes you realize how small we are, how brief. Earth has existed for 4.5 billion years, but humans have only been around for about 300,000 years. Civilization is maybe 10,000 years old. We've known about other planets for 400 years. We've been able to leave Earth for 60 years. In cosmic terms, we just got here. We just opened our eyes. And already we're finding worlds that might harbor life, planning missions to explore them, wondering if we're alone. Hashtag what happens next? NASA and other space agencies have big plans. The Europa Clipper mission will study Europa in detail, maybe finding plumes of water it can fly through and analyze. The Dragonfly mission will send a drone to Titan, a nuclear-powered drone that will fly around in Titan's thick atmosphere, landing at different sites to study the chemistry. There's talk of sending probes to Venus's atmosphere, of drilling through Europa's ice, of sample return missions from Mars that might finally answer whether there was ever life there. Private companies are getting involved too. Some are planning their own missions. Others are developing new technologies that will make exploration cheaper and faster. We might find life in our solar system within our lifetimes. Think about that. Within the next 20, 30, 40 years, we might answer one of humanity's oldest questions. Are we alone? And if we're not alone, even if it's just bacteria in Europa's ocean or microbes in Venus's clouds, it changes everything. It means life isn't unique to Earth. It means the universe might be teeming with life. It means we're part of something bigger than we imagined. Hashtag coming full circle. So, are there planets in our solar system where life could exist? After everything we've explored tonight, I think the answer is probably, maybe, hopefully. Mars had its chance and might still surprise us. Venus's clouds are a long shot, but not impossible. Europa and Enceladus have all the ingredients. Titan is doing its own weird thing that might lead somewhere. Even places we haven't seriously considered might have secrets. We're looking for life as we know it, but we might find life as we don't know it. We're expecting bacteria, but we might find something else entirely. Or we might find nothing, which would be its own kind of answer. The search continues. Right now, as you're drifting off to sleep, rovers are crawling across Mars. Spacecraft are orbiting Jupiter and Saturn. Telescopes are peering into the darkness. Scientists are analyzing data, planning missions, asking new questions. And somewhere out there, in an ocean under ice, or in clouds of acid, or in seas of methane, something might be looking back up at its sky, wondering if it's alone too. The universe is vast. Our solar system is full of surprises. Life is tenacious and creative and finds ways to exist in the most unlikely places. The odds feel good. Sweet dreams. And remember, every night when you look up at the stars, you're looking at possibilities. Countless worlds, endless potential, infinite mysteries waiting to be solved. We're not done exploring. We've barely started. The best discoveries are still ahead of us. Good night, fellow traveler. May your dreams be filled with alien oceans and methane rain and the endless wonder of what might be out there, waiting for us to find it.